Hello everyone, this is Shannon Henry, and today I will be discussing IMAPS and DNS for ISA 4220 System Security 2 in the fall of 2019. First, I will discuss IMAP, or the Internet Message Access Protocol. IMAP is an alternative protocol to POP3 that is used for retrieving email messages. It is a bit more popular currently than POP3 because people want to access their email on multiple devices, which there is support for in IMAP. IMAP is more like a remote file server that stores messages on the mail server itself rather than downloading them to a local device and deleting them from the server as with POP3. IMAP keeps messages on the mail server and allows users to view, edit, and delete messages without ever downloading them. For the modern day use case where people want to access their emails from their desktop, their tablet, and their cell phone, IMAP is a more useful protocol. Messages are sent from the sender's email server to the recipient's mail server using SMTP, where it will be put into the recipient's mailbox. Then the user is able to access their mailbox using IMAP. As with POP3, IMAP is sent in plain text. It will be transmitted over port 143. In order to more securely send information, it is best to use IMAP-S, which is the Internet Message Access Protocol over SSL or TLS. This way, everything that is sent is encrypted using the SSL-TLS handshake after that has been completed. IMAP-S uses port 993 for its secure connections. Here are some recommendations for hardening the IMAPS protocol on Dovecot for Ubuntu 18.04. First, we will need to configure the authentication mechanism. By default, the authentication mechanism is configured to allow authentication over plain text, which is much less secure than encrypted authentication. Disallowing the plain text authentication will make it more secure. Then, we should require that the system uses TLS for encryption. This is a well-known encryption method that will perform either a Diffie-Hellman key exchange or an RSA key exchange to encrypt the information as it is transferred. As with HTTPS, SSL 2.0 and 3.0 should be disabled, along with TLS 1.0 and 1.1, because all of those are older, less secure encryption methods. Lastly, we can install Spam Assassin, which will score each email to determine if it's spam and prevent mail from getting delivered to the user if it is, which decreases the likelihood that a potentially malicious email arrives to a user. Now we will talk about DNS, or Domain Name System. A domain name system is essentially the phone book of the internet. If somebody wanted to call Domino's to place an order for pizza, it's not enough for them to just know the name of the pizza place. They must convert that into something that the phone can understand in order to place the call. So a person would look up a phone number for Domino's and enter the number that is associated with Domino's into their phone to place this order. A DNS does just this for the computer. When somebody types in google.com, the computer must know the IP address in order to get there. So it will use DNS to look up Google's IP address and go to it. This is very important for users because it would be impossible to know every IP address of every site that they will ever need to visit, just like it would be impossible to know every phone number a person will ever need. The DNS converts the hostname of the site into an IP address. There are 4 different DNS servers that are involved in the process of loading a web page. First is the DNS recursor. The recursor is responsible for receiving and making additional requests to satisfy a client's query. The root name server is the next one, and it is step 1 in converting the host name into an IP address. It is something like an index that points the query in the right directions. The top-level domain, or TLD, name server is the next step into narrowing down the search for an IP address. It is what hosts the last part of a host name. For instance, .com, .gov, or .net. The authoritative name server translates the host name to an IP address and will return the requested information back to the DNS recursor. There is a 10-step process that gets the user from typing the desired web address to getting to that web page. Here are the steps. First, a user will type in the desired location, such as google.com, and a query will travel to the internet and to a DNS recursor resolver. Then the resolver will ask for more information from the DNS root name server. The root server will give the resolver the address of a top-level domain DNS server. For this example, it is .com if you're looking for google.com. The resolver will make a request to the .com TLD server. Then the TLD server will give the resolver the IP address of the domain's name server. The resolver will send a query to the domain's name server. Then the IP address for google.com will be returned to the name server. Then the DNS resolver will respond to the browser with the IP address of the requested domain. Finally, the browser will make an HTTP request to the IP address, and the server at that IP address will return the web page of the requested site. Here are a few hardening recommendations to keep the DNS servers on both IIS and bind more secure. First, we want to audit the DNS zones. This should be done frequently to review and test the domain names to ensure that they are working and up to date. Next, giving people less information about the server is always better. So hiding the bind version or the IIS version is always a good idea. This way, anyone who is trying to get more information about what is being run will not be able to know which version is used. This is good because you don't want to give more information to a hacker than you need to. It just allows them to know what vulnerabilities there are for that specific version. Hackers can attempt to use a zone transfer to have a better understanding of a network topology. So zone transfers should be restricted using an access control list and should only allow zone transfers on trusted IP addresses. Finally, disabling DNS recursion will prevent DNS and cache poisoning, which could allow an attacker to send altered information in response to a DNS query. Here are my works cited, and thanks for watching.